Math lesson number 24. Direct and inverse variations. Variation is a relationship between two variables in such a way that as one quantity increases or decreases, the other quantity also increases or decreases in a definite way. Direct variation is a variation wherein as one quantity increases, the other quantity also increases. And as one quantity decreases, the other quantity also decreases. So the formula is y is equal to kx, where k must not be equal to 0. K here is the constant of variation. Now the real example of this direct variation is the circumference of the circle, the formula. C is equal to pi d. Circumference is directly proportional to the diameter, d. So as the diameter increases, the circumference also increases. As the diameter decreases, the circumference also decreases. Therefore, this is a direct variation. Let's have the first example. If y varies directly as x and y is equal to 42 when x is equal to 7, find the constant of variation, equation of the variation, and graph the variation. Let's have the solution. Let's write first the formula. Y is equal to kx. Now substitute 42 to y and 7 to x and find k. So in this case, k is equal to 6. That will be 42 divided by 7. 6. And this 6 is the constant of variation. Since the formula is y is equal to kx and k is equal to 6, then plugging in 6, the equation now of the variation is y is equal to 6x. Now to graph the variation, we will graph y is equal to 6x. As a result, you have this. Now let's have number 2. If y varies directly as x and y is equal to 35 and x is equal to 5, find y when x is equal to 8. So first, write the formula y is equal to kx because this is a direct variation, varies directly. So 35 to y and then 5 to x and get k. So k is equal to 7. That's 35 divided by 5. And that 7 is the constant of variation. Now plugging in 7 to k, y is equal to 7x will be your equation of variation. Now find y when x is equal to 8. So you have y is equal to 7 times the x. X now is 8. So 7 times 8 is 56. So y is equal to 56 when x is equal to 8. Now using table, let's have here, if x is 5, y is 35, and if x is 8, y is 56. Now as you can see, as x increases to 8, 35 increases also to 56. So as x increases, y increases. That is a direct variation. Let's have direct power variation. This is a variation where one quantity varies directly as the power of the other quantity. So the formula is y is equal to k x raised to n, where k must not be equal to 0. And k here is the constant of variation. Now, the real example of this is the formula for getting the area of the circle. So area of the circle is equal to pi r squared. Pi there is the constant of variation. Number 3. If y varies directly as the square of x and y is equal to 36 when x is equal to 2, find y when x is equal to negative 3. So first, copy the formula y is equal to k x squared, y squared, because according to the problem, y varies directly as the square of x. Now substitute 36 to y and 2 to x. So this k times 2 squared is 4k. Now 36 is equal to 4k, k is equal to 9. That is 36 divided by 4. Now 9 here is the constant of variation. Plugging in 9 to k, so you have y is equal to 9x squared. That will be your equation of the variation. Now we will be using that equation to solve the problem. Now find y when x is equal to negative 3. Substitute negative 3 to x here. That will be 9 times negative 3 quantity squared. Negative 3 quantity squared is 9. 9 times 9 is 81. So that will be the value of y when x is negative 3. Now let's have this table. Square of x. If the square of x is 4, y is 36. If the square of x is 9, 9 came from negative 3 squared, y is 81. So as the square of x increases from 4 to 9, y also increases from 36 to 81. And that is a direct variation. Now let's have inverse variation. It is a variation wherein as one quantity increases, the other quantity decreases. Or as one quantity decreases, the other quantity increases. The formula is y is equal to k over x, wherein k must not be equal to 0 and x must not be equal to 0. K here is the constant of variation. Now, one real example of this is the distance is equal to rate times time, which can be written as t is equal to d over r. Now, t, the time, and the rate are inversely proportional because more time, less rate, or the higher the rate, the lesser the time. Number 4. If y varies inversely as x and y is equal to 25 when x is equal to 6, find the constant of variation, equation of the variation, and graph the variation. So y varies inversely as x, meaning to say this is an inversely proportional variation or inverse variation. Now another statement to indicate that the problem is an inverse variation problem is the inversely proportional statement. Now let's proceed to the solution. Y is equal to k over x, that's the formula of inverse variation. 25 will be substituted to y, 6 to x. Now find k. K is equal to 6 times 25, which is equal to 150, and that is the constant of variation. Now since the formula is y is equal to k over x and k is equal to 150, then the equation of the variation is y is equal to 150 over x because you are substituting 150 to k, the constant. Now, to graph the variation, we will graph y is equal to 150 over x. And the result is this. So this is the graph of an inverse variation. Let's have number 5. If y varies inversely as x, and y is equal to 25 when x is equal to 6, find y when x is equal to 15. So let's write first the formula. Y is equal to k over x. Then 25 will be substituted to y. X is equal to 6. So k is equal to 6 times 25, which is equal to 150. And that's the constant of variation. Now y is equal to 150 over x. That is the equation of variation. Now y is equal to 150 divided by 15, because we need to find y when x is 15. So 150 divided by 15 is equal to 10. Meaning to say, when x is equal to 15, y is equal to 10. Now writing that in our table, if x is equal to 6, y is equal to 25. If x is equal to 15, y is equal to 10. So as you can see, because this is an inverse variation, as x increases from 6 to 15, again, as x increases from 6 to 15, y decreases from 25 to 10. So this is an indication that the problem is an inverse variation.